Hello, we are going to start our second lesson in the linear function unit, unit 4, where today we are going to learn how to graph these linear functions. A linear function is any function that makes a straight line, either a straight one that's going up, which is a positive slope, one that's going down, which is a negative slope, one that's up and down, which is an undefined slope, or left and right, which is a slope of 0. So here in the do now, they first want us to determine the slope. To determine slope, we look for two real points on the graph. These were just two given to me, so I'm going to choose those. Then we ask ourselves, how much did we rise? How much did we go up or down? And then how much did we run? How much did we go left or right? So here we went down 1, which means -1, and we ran 1, 2, 3, 4, 5, 6. So my slope would be -1/6. And our y-intercept, if you remember from graphical features, the y-intercept is where does the graph cross the y-axis? And it crosses the y-axis right here at +2. So that is the point 0, because we didn't go left or right, 2. Or you could say y equals 2. All right. So today we are going to learn how do we graph linear functions using slope-intercept form. What is slope-intercept form? Slope-intercept form is a way that we can write equations. We will write these equations where we write y equals, then we have some number next to our x. This number next to our x, we use the letter m to represent it. And the m is the slope. The slope describes how much up, down, left, or right, or up or down our graph is going. It describes the shape of our graph. How steep is the graph? Then our b, the constant, the number that is being added or subtracted, that's the x-intercept. The y-intercept, I mean. That tells us where the graph is crossing the y-axis. So we are going to have something like y equals 2x plus 4. This would mean that my slope, because my number next to my x is my slope is x, or we could also call it m. And my 4, my constant, my number without a variable is b. And that is my y-intercept. That tells me that on my graph, I am going to cross at y equals 4. So let's look at this example right here. Determine the slope and y-intercept of the following functions. Your slope is whatever number is next to 2, and we use m to represent slope, so the slope here is 2. If I wanted to write this as a fraction, I could also say that this is 2/1. Alright? And my y-intercept is the constant, the number that's alone. The number that's alone here is -4. That's my y-intercept, which we use the letter b to represent y-intercept. Alright, this next example, y equals 3. My slope is anywhere I see an x. I don't see any x in that equation, meaning that my slope is 0, because I see 0 x's. And what is the number that I see by itself? The constant? It is 3. And remember, a slope of 0 is going to look something like this. So this means that this graph would be wherever 3 is, wherever y equals 3 is. All right. Now, individual practice, I want you guys to tell me what is the slope and what is the y-intercept of these following two examples. Pause the video and try this. So remember, slope is whatever number is next to x, which would be -3/5. And your y-intercept is whatever number is alone. Here, -7 is alone. So that is my y-intercept. My slope is whatever number is next to x, which is 4. And I don't have any number that's alone, so my y-intercept would be 0. It's important that we know how to find the slope and how to find the y-intercept, because we are going to have to use the slope and the y-intercept to graph. First thing we are going to need to graph is the y-intercept. First step will be for you to identify what the y-intercept is for the equation. You're going to be looking for the constant. And remember, the constant is the number without x. Then, once you know what your y-intercept is, once you know what b equals, you are going to determine if that number is positive or negative. If the number is positive, you would go up on the x-axis and put the point wherever it is. Or if the number is negative, you would go down on the y-axis and put the point wherever the point is, whatever number the y-intercept is. All right, so let's practice this. Here, identify the y-intercept from the following equation and graph it. All we're doing is putting one graph on the point. We're graphing the y-intercept. The y-intercept is whatever point, whatever number doesn't have x, the constant, which is right here, -6. That y-intercept is negative, which means I'm going to have to go down 6. So on my y-axis, this is my y-axis, I'm going to go down 6. So it would be 1, 2, 3, 4, 5, 6. This is my y-intercept right here. In a few minutes, we will also learn how to do the slope so we can have more points, but all we're practicing here is graphing the y-intercept. So now I want you guys to try this. First, think about what the y-intercept is, then think about if it's positive or negative, and then graph it. So the y-intercept, the b value, is the constant, the number that doesn't have an x, which is 4 here, which is positive, so we would have to go up 4. So on our y-axis, because we're talking about a y-intercept, we are going to go up 4. 1, 2, 3, 4, right here. Y equals 4. All we were doing right here is just practicing graphing the x and the y-intercept I meant. All right. Now, let's practice how do we graph the slope. Now, we are going to first do the y-intercept steps. We are going to identify what the y-intercept is, see if it's positive or negative, and then plot the point. Next, we are going to identify what the slope is. The slope is the number next to x. Once you know what your slope is, most of the time it will be a fraction. We are going to determine if our slope is positive or negative. If it's positive, that means that once we have the first point, we will be going up, and then we will be going right, and that will give us our next point. Or, once we run out of points that way, if we're at this point and we want to go down, we would go down and left. Why? Because if I look, these 2 points are going up, and these 2 points are going up. So that would be a positive slope. Now, if it's a negative slope, if this is your y-intercept, you would be going left and up. And why does that make sense? Because if you look, this 2 points are going down. But if you run out of points that way, you could also go to the right and then go down and plot your new point. And that would be going down. All right. So once you have your y-intercept and you use your slope, you can graph a few more points. All right, so let's practice this. First step is to identify your y-intercept. Your y-intercept is 1. 1 is positive, so go up to positive 1 on the y-axis, right here. Next step is to identify your slope. Your slope is -1 over 3. Okay, the -1 is negative, which means we would have to go down 1 and to the right 3, because 3 is positive. Or we can be going up 1 and to the left 3. You do whatever the opposite is. So starting at that y-intercept, we are going to go down 1 and to the right 3. 1, 2, 3, right here. Let's continue. Down 1 to the right 3. 1, 2, 3. Down 1 to the right 3. 1, 2, 3. I can't do any more points. So now I need to go the opposite. If I go up 1 and then to the right 3, I'm going to start making a weird shape that looks like this. I can't have that. I need it to be a straight line. So I'm actually going to have to go up and to the left 3. To the up 1 to the left 3. I went to the left 4 by accidentally. So up 1 and then 1, 2, 3. Up 1 and then 1, 2, 3. Then you are going to connect your points and put arrows. And get in the habit of labeling. This is the point y equals -1 over 3, x plus 1. This is that line. All right, let's try another example. First, start by identifying your y-intercept. Oh, I don't have any number that doesn't have an x, meaning y-intercept is 0. So I'm going to go to 0 and plot a point. Okay, now what is my slope? My slope is the number next to x, so it is 4. I need it to be a fraction, so I'm going to make it 4 over 1. So 4 is positive, so we're going to go up 4 and to the right 1, since both of those are positive. If we need to do the opposite, then we would go down 4 and to the left 1. All right, let's do this. Go up 4, 1, 2, 3, 4, to the right 1. Up 4, 1, 2, 3, 4, to the right 1. I can't go up 4 anymore. So now I'm going to go back to the y-intercept and go down 4, 1, 2, 3, 4, and go to the left 1. Down 4, 1, 2, 3, 4, to the left 1. Now I'm going to connect all these points. I'm going to put my arrows because they don't tell me when to stop, and I'm going to label it y equals 4x. Alright, now I want you guys to actually try this problem on your own. Think about how to do it. Start with your y-intercept, then do your slope. So my y-intercept is -2, which means I'm going to have to go down 2 and put my point. And now my slope is the number next to x, which is 1 over 4. They're both positive, so I'm going to go up 1 and to the right 4. So up 1, to the right 4. 1, 2, 3, 4. Up 1, 1, 2, 3, 4. I don't have room to do anything else. So the opposite of going up is going down, and the opposite of going to the right is going to the left. So going back to the y-intercept, I'm going to go down 1 and to the right 4. 1, 2, 3, 4. Down 1 to the right 4. 1, 2, 3, 4. And that's all I could do. Connect my points, put some arrows, and I'm going to write y equals 1 over 4x plus 3. And that is all. Let's try another example. All right. Y equals -6. Okay. I don't have any x there, which means my slope is 0. But I do have a constant, a number that's by itself is -6. So I'm going to go on the graph to -6. And then I can't go up or down because it's telling me 0. So I'm literally just going to stay on -6. Anytime you have a graph that is y equals, it is going to be a horizontal line. If you had a graph y equals 3, that means you would just go to 3 and you would put your horizontal line. Why does this make sense? If you label this point, you would tell me you went to the left 6 and you went up 3. If I told you to label this point, you would tell me you didn't go left or right, but you went up 3. If I told you to label this point, you would tell me you went to the right 7 and up 3. In all 3 of those points, y equals 3. Now let's look at this one. X equals 5. X equals 5 means you have to go to the x-axis and find 5. And you want every point to be at x equals 5, so it's going to go up and down. So, any point that is y equals a number is going to be a horizontal line, and any equation that is x equals a number is going to be a vertical line. Alright, we are now going to move on to some Regents questions with what we learned today. So let's look at this first Regents question. What is the y-intercept of the graph whose equation is y equals -2 over 5x plus 4? Well, the only two numbers I see here is -2 over 5 and 4. So my answer is either going to be -2 over 5 or my answer is going to be 4. So it's not going to be choice 1. And I'm not really sure how they got 0, so it's not going to be that. Now, if you remember, the equation we learned is y equals mx plus b. M being our slope and b being our y-intercept. So if we are trying to find the y-intercept, we are looking for the b value. B value is whatever the constant is, whatever number doesn't have x, and that would be number 4. Nice, easy question to get correct. All right, let's look at this next one. Regents question. On the set of axes below, draw and graph the equation. All right, let's start with that. So first, let's identify our y-intercept, our b value. That is 3. That means we're going to start by going up 3 and putting a point. Up 3 and putting a point right there. Good. Now our slope is the coefficient of x. So our coefficient here is negative 3 over 4. Always give the negative number to the top number. So the top number tells us about rising. If we're rising negative 3, that means we're going down 3. And the bottom number tells us about running. If we're running 4, positive 4, that means we're going to the right 4. So starting at this point 3, we're going to go down 3, 1, 2, 3, and we're going to go to the right 4, 1, 2, 3, 4. We're going to continue. Let's go down 3 again, 1, 2, 3, and go to the right 4, 1, 2, 3, 4. Nice job. I might have went 5. Let me just double check. Down 3, 1, 2, 3, and over 1, 2, 3, 4. No, it's good. And I'm not going to have space to do any more. So I could also go up 3 and to the left 4. Whenever your slope is negative, just either the top number or the bottom number needs to go in the negative direction. Here, the negative direction is left, so we're going to be going up. So up 3, 1, 2, 3, to the left 4. 1, 2, 3, 4. Up 3 again, 1, 2, 3, to the left 4. 1, 2, 3, 4. Nice job. Now with these, you connect the points and you write down y equals negative 3 over 4x plus 3. Because our slope is negative, we should end up with a line that is going down, which we do. Now the Regents also asks us this question. Is the point 3, 2 a solution to the equation? Well, let's see. If I try to go to the point 3, 1, 2, 3, and up 2, that would be this point right here, which is not on our line. So we would say 3, 2 is not a solution because it does not fall on the graph of y equals negative 3 over 4x plus 3. It would have to fall on that blue line in order to be a solution. And our graph justifies this. All right, let's go look at another Regents question. Which graph shows a line where y is, the word is, equals, is 3 more than means we add half of x. Half of x means we multiply x by a half. Okay, so first thing I do is look for my y-intercept. My y-intercept is the number without x, the constant, which here is 3. So I'm looking, which one here starts at 3? That one does, not choice 1. Choice 2 starts at 3, and choice 4 starts at 3. Okay, all of those could be a contender. Now, if we're half of x, that means our slope is 1/2, meaning that we would be going, our line would be going in upwards motion. So our answer can either be 3 or 4. Okay, to go 1/2, since your top number is positive, and that number means to rise, we would go up 1, and the 2 tells us that we go to the right 2. Well, let's see. If I go up 1 and to the right 2, oh, well, we already said that's not our answer, so let me not look at that one. Up 1 to the right 2, that looks good. Up 1 to the right 2, that looks good. Let's see the other direction. We would go down 1 and to the left 2. Well, if I go down 1, oh, I was going the wrong way with this one. If I went up 1 and to the right 2, I would not be at the graph. So the answer is actually choice 2. Because up 1 to the right 2, that would not work for choice 3. So yes, the answer is choice 2. Now let's look at this last question. Which graph represents x equals 2? X is your line that goes left and right, meaning that we would go to the right 2. The right 2. That could be the answer. This is going up 2, so that can't be my answer. The right 2 would be right here. No good. And no good. We know that any equation that's x equals is going to be a vertical line. So those are the Regents questions. That wraps up our lesson.